There are three types of row operations that can be performed in the row of a matrix. If a matrix B is obtained from matrix A by performing row operations, we say that A is row equivalent to B. And we are going to write in this way A, and we are going to read it in this way. A is row equivalent to B. There are three types of row operations, and the first that I'm going to speak about is the row swap. Switching two rows of a matrix. That's what we are going to do. If we switch row I and row K, we are going to write Ri and this double arrow Rk. So anytime that I see beside a matrix this operation, it means that I'm going to switch Ri, row I, and row K. For example, if A is this matrix that have these elements A sub 1, 1, A sub 1, 2 until A sub 1 n in the first row, and we have a similar row here, let's call it row I, and with more rows we have another row K, and the last row at the end, in this case we have a matrix that have m rows. And we see beside the matrix the operation Ri interchange with Rk, so it means that we are going to switch these two rows. So when we type the matrix, the result of making this operation is just switching these two rows here. The matrix that result will be row equivalent, so I can write here row equivalent, and the matrix that result has in the place where was row I is now row K, and in the place where was before the row K is now row I. So this operation just leave the other rows exactly as they are and just change these two rows, just switch these two rows. This is the first operation we can make in the row of a matrix. The second one is what we call row multiplication. What we do is multiplying a row by a scalar, so by a real number. So if we multiply row I by the scalar lambda, for example, what we are going to write is lambda Ri will be substituting Ri. So we use this double arrow to symbolize that the row I will be changed by the same row I, but now multiplied by lambda. So for example, if we have a matrix A like this, so we have all similar to the previous one, but we are going to be focusing in the row I. And if we write beside this matrix this operation, it means that the row I, so this row, will be multiplied by lambda. So we're going to change this row, the rest of the matrix will stay the same. So the answer will be a matrix like this. So they have the same rows, all the rows are the same, but in the row I will appear multiplied by the scalar lambda. So that will be making this operation. Obviously, the matrix that we obtain is row equivalent to the previous one. And finally, the third operation is called row addition. So what we are going to do is replacing one row by the sum of itself, so the same row, and a multiple of another row. So we are going to write in this way: Ri plus lambda another row. So the row I will be to the row I will be added lambda times, so on a scalar lambda in this case, could be 5, could be 6, whatever is scalar, multiplied by Rk. And that will be substituting to the previous Ri. So it will be the same Ri that you see, plus another row multiplied by lambda, by the multiple of another row. For example, if we have again the same matrix, and we have one row that is the row I, another row, the row K, and we see beside this the operation Ri plus lambda Rk will be substituting Ri It means that this row, that is the row I, will be substituting instead of this, will appear the same row plus lambda times the row k. So the answer will be a matrix that have the same rows, except that the row I will be substituted by the same row I plus lambda times the elements in row k. For example, the first element will be the first element of row I plus lambda times the element in the row k, the respective element in row k. The second element of this row will be the second element plus lambda times the second element of row k. And so on. Every element will be substituted by the same element plus lambda times the corresponding element in row k. That will be the operation, the row addition. So we'll be adding to a row another row that has been multiplied by a number. Let's see some examples. Assume that we have this matrix A equal minus 1, 2, 7, 2, 0, negative 5, etc. So this is a 4 by 3 matrix. And we see beside this matrix the operation R3, R1. So means that we are going to switch R3 and R1. We are going to swap these two rows. So the equivalent matrix will be another matrix in which the other rows remains the same. For example, the second row remains the same. The last row, minus 1, 0, 3, remains the same. But in the first row, we're gonna see that was before row 3. So here will be minus 1, 2, 7, and in the first row I'm going to type 4, 4, minus 6. So that will be the new matrix, and this matrix will be row equivalent to the previous one. This is an example of a row swap. An example of row multiplication could be something like this. We have a matrix, let's see the same matrix, and assume that beside the matrix we see 3R4 is going to substitute R4. So it means that this R4 will be substituting by the same row multiplied by 3. So the answer will be a matrix in which the other rows remains the same. The first row doesn't change, the second row doesn't change, the third row doesn't change, but in the last row, instead of minus 1, we're going to have minus 3. We're going to multiply by 3. In here will be 3 times 0 is 0, and here will be 3 times 3, 9. So it will be minus 3, 0, 9, the elements in this row. And that will be the new matrix. This matrix is row equivalent to the first one. Finally, the last one, row addition. Assume, for example, that we have the same matrix, minus 1, 2, 7, etc. And we see beside this the operation R1 minus 2R4 are going to substitute R1. What does it mean? That this row is going to change. Row 1 is going to change. And what will be changed? It will be changing by the same row minus 2 times row number 4. So it means that the other rows, second and third, doesn't change, and the fourth row doesn't change. The only row that's going to change is R1. And I say substituting R1. It means this is the only row that is going to change. The only operation when the two rows change is in the first one, when we are actually switching the two rows. But in this case, is the only R1 is going to change. So this will be row equivalent to 2, 0, minus 5. There is no change in the second row. There is no change in the third row. There is no change in the fourth row. But the first row will be the same first row minus 2 times the 4. So it will be minus 1 minus 2 R4 minus 2 times minus 1. That will be actually plus 2. Will be minus 1 plus 2. So it will be 1. 2 plus minus 2, 0 times 0. 2 times 0 is 0, so it will be 2 minus 0 is 2. And here, so there is no change in here. And this will be 7 minus 2 times 3. It will be 7 plus minus 2 times 3. So it will be 7 minus 2 times 3. So 7 minus 6. 7 minus 6 is 1. So the first row will be 1, 2, 1, and close the bracket. So this will be the new row. We have changed the first row that was minus 2, minus 1 to 7 by a new row that was the first one plus minus 2 times R4. And with this explanation, I finish this video. Thank you.